Hi guys. In this example problem, we're actually going to deal with Bernoulli's equation, which is an equation that shows us the relationship between density, pressure, flow velocity, things like that. These are really important questions to understand, so I figured I'd give you guys an example. In this specific example, we're looking at this tube, and it's shown in this figure. There is a flow rate of 1,100 centimeters cubed per second. And then we're trying to find the height of the mercury in the right side of the U tube. So the first thing we're going to do is convert the flow rate and convert the diameter length. Then we're going to calculate the radius by dividing that diameter length by 2. So then we're going to calculate the area of the first end. We do that by substituting in that radius 1 that we found. Then we're going to solve for V1 using that area, and we do that by just kind of rearranging the equation a little bit and then plugging in the numbers that we found in the previous steps, and we get 3.503 meters per second. So then we kind of carry those steps out again, but this time for the second end. So again, finding that area, finding the radius, and then solving for V2 in this case, and we find V2 to be 87.58 meters per second. And so now we're going to apply Bernoulli's equation. So we're just kind of plugging in all the values that we found throughout this problem, and we end up finding that the difference between P1 and P2 is 4,899.62 PA. And now last couple of steps here, we just find that difference and we use it to solve for the height. We just kind of rearrange that equation that you'll see up there and then plug in all of our knowns, and we find that the height is going to be 4.3 centimeters. So that is it for this problem. Email me if you guys have any questions or schedule a session. Hopefully this was helpful.